start recording now. So you're already on. You can start now.
Okay, sir. Are you there, sir?
Yes.
All right, sir. This is Ogunranti Abiola. I'm representing Group 1, and we'll be talking about modeling for problem A, and that is on the case of oil agglomerate from the Deepwater Horizon accident. The name of the group members are Ogunranti from Obafemi Awolowo University, Ilefe. We are talking about depth. We want to relate depth and city with the microbial activities in order to know the rate at which mass will decay underneath. And then I come with the assumptions. The greater the depth, the lower the microbial activities. Therefore, the lower the rate of change in are developed this way. We assume change. Porosity with time is inversely change in mass with time is inversely proportional to the depth. Also, change in mass with time is that proportional to porosity. There is mistake in the PDF. Okay. Also, that means if you combine, sir.
Yes, go ahead.
If you combine this, you can say change in mass with time is directly proportional to porosity and inversely proportional to the depth at which the clump is buried. So from here, we can introduce constant K, which is the MDT is equal to Kp over D. Now, for the simplicity of the equation, we have to look for the relation between depth and porosity with mass. And that gives us change in porosity with time is directly proportional to mass of the clumps and the porosity of the soil. Change in porosity with time. Change in depth with time, not porosity this time. Change in depth with time is directly proportional to the mass and the porosity. From here, we also have that means if you introduce constant, we can get change in depth with time is equal to C, M of T, P of T. Now from here, if you find the second derivative of this first equation, which is the MDT is equal to Kp over D, we will have that the second derivative, we give K into bracket 1 over D dp dt minus P over D squared d dt. In order to simplify the equation to equation with one problem to tackle, we have to look for a relation by which you can remove P and D from the expression. So from here, we can say from equation 1 and equation 2, which we have that dp dt is directly proportional to D of T. Since we know that, and that means change in porosity with time can be represented in terms of depth. So we can remove this the D we have there initially, dp dt, and represent it with something like UT. ED. Sorry. Now from here, we simplify the equation to get second derivative of M is equal to constant R2 into brackets first derivative of M with respect to T times M of T minus R2 equals 0. Now, this equation can be tackled using by developing an eigenvalue problem. From here, we can draw the graph and look for stable and unstable points to get out our solution of the equation.
Okay. Go ahead, or is that all?
And then from the assumptions, I want to throw more light to the assumption. The reason okay. I think the assumptions are clear enough. I don't know
Yeah, the assumption are clear now.
if I'm okay with that.
You want to go over the assumption again? Let me listen.
Not really, sir.
Okay. Let me ask this question. Your second derivative, there is a place you write from 1. We have the square m dt squared equals kd over dt times p over d. Can you see that equation?
Is the equation
The second
yes.
differential equation. Can you see it? I want to ask how you got that equation. Because I know the first equation you have is the m
The
dt.
equation was gotten from yes, the mdt is equal to p kp of t over d of t. Then from that, I find the second derivative for the mdt.
Okay, you find the
And
second
that's my
derivative.
equation 1. Second derivative for the mdt.
Yeah. And k is a constant. Okay, so that's why you
Yes,
have
sir. K is a constant.
kd dt of p over d. Okay, I got it now.
Yes, sir.
I get it now. I got it now. And that first equation came from the idea that the rate of decay or the rate of growth of the crumb or of the amount of the crumb is directly proportional to porosity
So
and inversely
and
proportional
inversely
to.
to the depth. Yes, sir.
Okay. Okay. I don't know what your idea is. What if that equation 1 is written as, that's your first equation, it's written as dm dt equals kp of t minus another constant d of t.
Minus d of t.
Yes, instead of over d. Minus alpha d of t. What do you see to that idea? That idea means, this is where I'm coming from, it means m increases as p increases, while m decreases as d increases. Do you ever think of that? Hello?
Yes, sir. Can you hear you, sir?
Can you hear me very well?
Yes, I can hear you now, sir.
I said, what do you have of that? What is your what's your opinion about that?
Okay, like the dt is equal to
K,
p minus
kp of t minus alpha d of t.
alpha d of t. Uh, I think that will be okay, but
The reason I took that is if you do that, it means m increases because the m dt, if you say assume k is positive or k is always positive, Oh, it means M will always increase as P increases, and M will
And
always decrease as D increases because the rate is negative and the rate is positive when considered with respect to P. Hey, I think I should stop recording. Sorry.